Hello students, in the previous video we started with the we can say that the periodic classification of elements. We have seen about the we can say Doberan's triad. We discussed about Doberan's triad. We discussed about we can say Newland's octaves of music. We discussed about the we can say that the Mendeleev's periodic table. We have seen that at the time of Doberan 30 elements were there in the nature. At the time of Newland 56 elements were present in the nature. At the time of Mendeleev 63 elements were present in the nature. And all these three, Doberan, Newland or we can say Mendeleev, they took the fundamental property that is the atomic mass number. They classify the elements on the basis of atomic mass number. According to them, atomic mass number is the we can say fundamental property of element. We know that the elements has the two characteristics, atomic number and atomic mass number. So Doberan, Newland and Mendeleev took the we can say that this atomic mass number as a we can say that the fundamental property. But after we can say that this rejection of the Mendeleev's periodic table, as the Mendeleev's periodic table he classified all the elements present at that time, but because of the entry of the we can say that the last zero group elements, that table got disturbed one. Some elements which were having the we can say that the more atomic mass, they came before the we can say the elements having the less atomic mass number one. So you can see in the table one, the argon and we can say potassium. Argon has the atomic mass number we can say that the 40 and that of potassium is 39. But argon come first and then afterwards potassium. So that table got disturbed one. We discussed demerits also. Because of that demerits one, we can say that that table was discarded. After that, after we can say Mendeleev, then one more scientist, that is Moseley. He prepared we can say that the new table one. Now according to Moseley, the atomic number is the we can say that the fundamental property. Atomic number, not atomic mass number, because the three earlier scientists took the atomic mass number as a fundamental property and they classified one, but they could not succeed to classify all the elements present at that time. Now mostly we can say consider the atomic number is the fundamental property. See, we learned in the last year about the atomic number and atomic mass number. When we say atomic number means we can say that the number of protons, or we can say that the number of electrons in an atom. It is called the atomic number. Number of protons or number of electrons in an atom is called atomic mass number. Atomic number. Now what happens if you see the structure of the we can say that the atom one, the nucleus which contains the we can say that the protons and neutrons, and electrons are revolving around the nucleus in a different we can say that the shells one. So these are the shells, that is the energy levels of the we can say atoms. We also call the orbits. In that different part, in the different orbits, there are the we can say that the electrons are there. So that we learned in the we can say that the last year about the we can say that this atomic number one. Also we learn about the we can say that the electronic configuration of the atom one. Suppose any atom is there. Suppose we can say that the sodium atom is there. Now sodium atom which has atomic number 11. Atomic number 11, it means it has the 11 protons. What we are saying? Atomic number means we can say that the number of protons or number of electrons. So when we say atomic number is 11, it means the sodium has the we can say that the 11 protons. And as atom is electrically neutral, it means it doesn't have any charge. So number of electrons also we can say 11. So in any atom, number of protons and the number of electrons are always equal. So as it contains, we can say that the 11 protons, it means it must contain, we can say that the 11 electrons. The number of protons may be different one. Or it, here in this case of the, we can say that the sodium, it contains the 12 neutrons. So we just concentrate on the how these electrons are, we can say, distributed in the different energy levels or different shades, you can say, or different orbits, you can say. So here in the first orbit there are, we can say, 2 electrons are there. Second orbit there are 8 electrons are there, and remaining electrons present in the last orbit. So each shell has the, we can say that, the capacity to hold the electrons. The first shell has capacity of holding 2 electrons, maximum or minimum, we can say that, that it can hold 2 electrons. One second shell is there, its capacity to hold 8 electrons, and then the third orbit is there, third shell is there, it has capacity to hold 18 electrons. If you remember, last year you studied about the, we can say, one formula 2n square. This formula indicates that if you take n equal to 1, n equal to 1 means we can say that the first shell, that is called as a K shell. If you remember, it is K shell, n equal to, we can take 1. For K shell, it is n equal to 1, that is the first, we can say that here, this K shell. And if you put here 1, that is 2 multiply 1 square, we get here 2. 1 square is 1, so 2 multiply 1, we get answer 2. So its capacity of holding 2 electrons. Similarly, suppose the second shell is there, it is called as a L shell. L shell, that is the second orbit, when n equal to 2, it is called as a L shell. Here you have to put n equal to 2. So 2 into 2 square, 2 square is 4. So 2 into 4 equal to 8. So the second shell is there, it has capacity to hold 8 electrons. That is how we can say here 8. If you put n equal to 3, that is called as a M shell. M shell, n equal to, we can say that is 3. So here 2 into 2 cube, it is 2 into 8. Sorry, 2 into 3 square here, n equal to 3. It is 2 into 9, that is, we get here 18 electrons. This third shell has capacity of holding 18 electrons. Similarly, if you put n equal to 4, means n shell, here 2 into 4 square, that is 2 into 16, it will come 32. Means the fourth shell will be there, it has capacity to hold, we can say that is 32 electrons. So, like this distribution is there, distribution of electrons in the different shells, it is called as a electronic configuration. It was there last year, so just I have revised that one. Electronic configuration, atomic number, how electrons are distributed in the different orbits. So like this we can say that is now mostly took the this property, atomic number is the fundamental, we can say, property in classification of the elements. He also made the law. How this we can say, Mendeleev made the law, he also made the law, he also prepared the table. So let us see the law and all this, the table he made. Now the law he made, the law was, we can say, called as a modern periodic law. You see the table one, the table is called as a modern periodic table, and he called as a that law as a modern periodic law. So what he said that the properties of elements are periodic functions of their atomic number. See the Mendeleev periodic table, Mendeleev periodic law. Only difference is here. Properties of elements are periodic functions of their atomic masses. That was the Mendeleev periodic table, Mendeleev's law. This Moseley's law, that is the modern periodic law. Properties of elements are periodic functions of their atomic number. Means what? As the atomic number changes, As the atomic number changes, the chemical property of the, we can say that element also change. After certain interval, is called periodic. After certain interval, again we get the element which has a different atomic number, but it shows the properties of the elements which are shown by previous elements one. So that classification is done. So that table is called the, we can say that the modern periodic table. It is a periodic means after certain interval again we get the element having similar properties one, and that you have to treat that elements you have to keep below the element means we can make the, we can say table, and one below the other that elements can be kept one. Here also we can say that the mostly make the table one. In that table we can say that the vertical columns are there, horizontal rows are there. The vertical columns same as in the middle is here also vertical columns are called as a groups, and horizontal rows are there that are called as a periods one. So in that table there are columns are there and horizontal rows are there that are called the, we can say that the groups and periods one. Now in this the table that we made, it is called modern periodic table. In that table if you see there are the, we can say that the total there are the 18 columns are there. I just draw the outline one. Here we can say that the elements like this, we can say that there are the, we can say elements are there. It is kept in this table. So here we said first column, that is the first group, second group. Here is, we can say that the third group, fourth group, fifth group, sixth group, seventh group, eighth group, ninth group, 10th group, 11th group. So here third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. Then here 12, 13, 14, sorry, here this 12 is there. Here 13, 14, 15, 16, 17 and 18. So we can say that here first group, second group, then 3 to 12 here in middle, and 13 to, we can say that the 18 here. Means here we can say the right table, and downside there are the, we can say that the two series are shown over here. Just I have shown the, we can say that the this outline of that, we can say periodic table one. In that table, first group, second group, third group, fourth group, fifth group, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Like this 18 groups are there, 18 vertical columns are there. And it contains, we can say that the there are the 7 periods are there. 1, 2, 3, 4, 5, 6, 7. Yes, here like this we can say that there are the 7, we can say that the periods are there. So like this you can see in that table one there are the, we can say that the 7 periods are there and 18 vertical columns are there. Okay, so just I have made that outline one. Then you can find out that all together there are the 118 boxes are there. Means there are the, we can say that the 118 elements are placed in that table. So this table here we can say that the all elements which are present till now at present, whatever elements are present in nature, or we can say even which are prepared in the lab by scientists one, all the elements are kept in this table. As this table is, we can say that the completely classified elements one, it is called as a modern periodic table, also called as a long form of periodic table. And all the elements are which are kept here, they are kept according to, we can say that the electronic configuration. Means every element which is kept in the, we can say that box one, after we can say finding its configuration one, electronic configuration, and then it is kept in the each box. Now just I will tell you one roughly. Suppose we can say that the element here is kept here, the thing is Li. So this Li is kept, its atomic number is, we can say that 3. So its configuration is, in the first orbit, in the first shell 2 electrons are there. We know the first shell has capacity of 2 electrons, and the remaining 1 electron is there. Now 3 minus 2 is 1. That electron will go into the, we can say that the next shell. This here K shell contain 2 electrons, L shell contain, we can say 1 electron. So it is kept here. So every element is there. Now we discuss how it is placed on, why it is placed here only, one and other place. So that we discuss afterwards. But each and every element we can say that we kept in the table according to the, we can say that the electronic configuration. That's why what happened, all the elements are there. It is fully, we can say that we kept in the table. So dear students, now we discuss about the, we can say just the outline one. The remaining part we'll see in the next video one. But before that, I will just give some, we can say, assignment to you. I taught you about the Doberan style. I taught you about the, we can say that the this Newland's octaves of music. I taught you about the, we can say that the Mendel's periodic table. All this, we can say that the classification was based on the atomic mass number. Now what you have to do, you have to write short notes on, we can say that the this Doberan's triad and the Newland octaves of music. What you do, you write the short note on Doberan's triad, okay, and also Newland's octaves of music. And the third question will be there, where you will write the, we can say that the this one now, merits of the Mendel's periodic table. Merits. Fourth questions will find out that you will write the, we can say that the demerits of the Mendelian periodic table. Means today I will give you 4 questions to you. First question we will write the short note on Doberan's triad. Second questions we will find out that we can say that the short note on the Newland's octaves of music one. Third question is there, you have to write the Mendeleev's merits of the Mendeleev's periodic table, and we can say that the fourth question is there, that is the the merits of the Mendeleev's periodic table. Okay, thank you.